Chapter 7 is about confidence intervals. We're going to be making a confidence interval for a mean, a proportion, and a standard deviation. The idea of a confidence interval is that you're going to have some data, some type of sample data, and at the end you'll be able to say, well, I'm pretty sure the proportion is between 54 and 57%. Of course, we can't be 100% sure that that's true for the whole population because it's based just on a sample. So we'll end up saying, well, I'm 95% sure that the following statement is true. Usually we write the confidence intervals like this as decimals. P is between these two, 0.54 and 0.57. So the next question is, where did these two numbers come from? Well, a while ago, we used to say that a score is unusual if it's more than 2 standard deviations from the mean. So basically, we would do something like this. The P hat is the sample percentage that came from our sample, and then you could say add on 2 standard deviations, subtract 2 standard deviations. That's where we're going to get those two numbers from. But now we can be a little more accurate rather than just saying 2 standard deviations away. Since we now know how to use table A2, instead of using 2, we could be a little more accurate and say, well, I want to use 1.96 standard deviations, or I want to have it 2.33 standard deviations from the mean. Why those two numbers? Well, that's where that idea of 95% confidence comes in. If you are using 95% confidence, we would use this. Perhaps you want to be more confident, 98% confidence, then you would use 2.33. So basically, you can say there's the sample percentage, and then it can't be 100% accurate, so we're going to have some error. That's what this E is. And so the interval comes from, you say, take the sample plus the error, take the sample minus the error. So here's a small example. I say there's an 8% chance of rain, but my prediction could be off by 2% plus or minus. So then the confidence interval would look like this. The percent or chance of rain is somewhere between 6 to 10%. All right, that was a beautiful overview, but what is it that we really need to do? So the error. The error when you're talking about proportions is going to be, here's the z value, which we're going to get from table A2. This is the sample proportion p hat, and q is always equal to 1 minus p. So these z's are called critical values. Like I said, we get those from table A2, and here's our first example. Let's say you want to be 95% confident. So first of all, draw the bell-shaped curve. Next, you put 95% in the middle. Then there's this cutoff, and cutoff over here. And so if we're 95% confident, that leaves 5% for these two end pieces, which are called tails. So if you cut 5% in half, it's 2.5%. So half of it goes over here, and half of it in the right tail. So the next thing to do is use table A2. What I'm going to do is I'm going to look up this one, because this area right here corresponds to this. So I can get the answer directly from this table. What I need to do is look through and find what's closest to 0.025. Now I've done this before, so I know that it's in here somewhere. Here it is. It's right here. So that means that if you look to the left, it says negative 1.9, and if you look straight up, it says 0.6. So it's going to be negative 1.96. Then the good thing is the graph is symmetric. So if it's negative 1.96 on the left, then it's positive 1.96 on the right. So there are our first critical values. Now for a full example, top to bottom, here's everything. So 413 people out of 1,000 said they approved of the job the president was doing. Now make a 98% confidence interval. So first of all, I would write down the data. N is 1,000, x 413. You divide them, that's where the p hat comes from, the sample percentage, 41.3%, although we usually use the decimal form. The next thing is draw that bell-shaped curve. Since we're using 98% confidence, then that 98 goes in the middle. So the alpha is what's left over, 2%. Cut that in half, 1% on each tail. Again, use table A2. It's easier to look up the negative one. So this is 0.01, this is 0.01, so look for 0.01. What about that one? Well, this one is off by 0.002, but this one is only off by 0.001. So this is the winner, winner, chicken dinner. So if you look to the side, it's going to say z equals negative 2.3, and look up, and it's 3. So negative 2.33. And likewise, the other one will be positive 2.33. The next thing to do is do the error formula. So that's the 2.33, z goes here. This is the p hat, and this is the q hat, 1 minus 0.413. Divide by the sample size and take the square root, so here's the error. So this is essentially saying the approval rating for the president is 41.3%, but it can be off by plus or minus 3.6%. So that's the next part we do. Add the error on one side, the right side, subtract the error on the left side. And there's the confidence interval. Another example. So, from this point on in the semester, we're going to be using the TI-84 graphing calculator more and more. So how do we do this with the graphing calculator? We're going to use 95% confidence for the proportion of children that watch TV before bed. So 43 out of 104 watch TV just before bed. So you go to Stat, and then move right to go over here until it's highlighted with tests. And then move down, down, down until you find the 11th thing on the list. The 11th thing is one proportion. So we've only got one sample, so it's one proportion. And it's a Z because we're using table A2. Then hit enter. The next thing is it will say what's X and what's N. And then you put the confidence level as a decimal, 95%. And then move down here, and this is blacked out because I was pressing the enter key. So you press enter, and ta-da, it gives you the confidence interval. So somewhere between 31.9% and 50.8% of children watch TV just before bed. There's the confidence interval. So when we did number 3 and did all those formulas and looking up the chart and stuff like that, it was great fun, but that was mostly just going to be one time we do it the long way to understand where it came from, and from now on we're going to be using the calculator. All right, one last thing. What if you only had this answer? Could you find out what the p hat and what the e is? So look at this fancy artwork. The idea is that the p hat is in the middle. You would then add the error to find this number on the right. You would subtract the error to get this number on the left. But this is in the exact middle. If it's in the exact middle, all you have to do is average those two numbers, and you would get the p hat equals 0.413, which I remember from the other page is true. Now, what about the e? Well, like I said, it's supposed to be you take p hat, add the error, you get to this side, p hat minus the error, you get to this side. That means I could plug in p hat right here, say plus e, and then it would have to equal this 0.508. Then just subtract 0.413 from both sides, and you would find the error, 0.095.